Alright, so today we're going to talk about the um, notation for binomial distribution. And in your book, they give the notation as B, um, X, and then NP. So X is the number of successes, N is the number of trials, and P is the probability of success. Well, you can use Excel to figure out this notation, this calculation. So the Excel part is BINOMDIST, and then you have X, N, P, and then true or false. So let's run through an example. Do a new page. Let's say we wanted to figure out so in this problem it says the probability of success is 0.5. You have 9 trials. You want to know the probability that you get exactly 2 successes. Okay? So when you do this in Excel, this is the command. The first number is always the number of successes. The second number is the number of trials. The third number is going to be the probability of success. And since we want to know exactly 2, even though it doesn't say that, it's implied when you see this notation. Exactly 2, you're going to put false here. Okay? So when I calculate this in Excel, I get 0.070313. Get a long number. Alright? So basically you're calculating the probability that you get exactly 2 successes out of 9 trials. Sometimes you'll be given another problem and it might look like this. They want you to figure out the probability that the number of successes is in between 1 and 4. And let's say we still have the same scenario. We have 9 trials, and then we have the probability of success as 0.5. Okay? So what you're going to have to do here is you're going to have to figure out the probability of each one. So you're going to put in the probability that x is equal to 1 plus the probability that x is equal to 2 and then 3, and then you're going to go all the way up to 4. Now Excel won't do the numbers in between. What you're going to have to do is get Excel to do each one. So if we just do the first one, it's BINOMDIST. So the first number is the number of successes is going to be 2. The number of trials is 9. Probability of success is 0.5, and then we're going to put false here. Okay, so you're going to repeat this for each number. You're going to do it again, except the next time you're going to change it to 2, and so on, all the way up to 4. So you're going to get Excel to do it. You're going to get a number here. You're going to get another number here. I didn't calculate this out. And you're going to keep going until you get all 4 numbers, and then you're just going to add them up. I believe when I did this problem, I got 0.497961. So the probability that the number of successes is 0.497961. So you can double check that yourself. Okay. And another problem that you might see is the probability, let's say we want it greater than or equal to 2. And once again, same scenario. You can do the probability that x is equal to 2 plus the probability that x is equal to 3, and you keep going all the way up to 9. But that might take you a little bit. An easier way to do this is the probability that x is greater than or equal to 2 is the same as saying 1 minus the probability that x is less than or equal to 1. So what you can do is you can find the calculations for this, find the probability of this, and then subtract that number from 1. So you get the same answer, or you can do it the long way. It's up to you. Alright, hope this helps.